In this video, we're going to look at acid-catalyzed esterification reactions. So the general reaction scheme is shown below. In this reaction, we have a carboxylic acid, represented by the group R1, and we have an alcohol. This reaction is called a condensation reaction because we're going to remove water from between these two molecules. That makes water a byproduct in the reaction, but we typically only write our organic products. This reaction is acid catalyzed. So if you remember from thermochemistry, a catalyst is something that is present in the reaction, but is not used up. It's not actually part of the reaction, so it's regenerated during this reaction. So at the end, we have our R1 group from our carboxylic acid, and we have our R2 group from our alcohol. And the two are bonded by an ester linkage. So we're going to look at an example now. In this example, we have our acid and our alcohol. We're going to start by just naming our acid and alcohol, so we can see how the name of these relates to the actual name of the ester we form. So our acid name, 1, 2, 3, 4, so it's 2-methyl-butanoic acid. So it's a 4-carbon acid with a methyl on the second carbon. If you need to refresh acid naming, you can go to the carboxylic acid video. Our alcohol is a 4-carbon alcohol, so it is butan-2-ol. It's a secondary alcohol. The OH group is on the second carbon. So when these join together, we're going to be removing the water from between them. So we're basically just going to smush these two structures together. So I'll draw my alcohol, or my acid basically the same. Draw my O from the alcohol. And then I have this structure here. You may draw the alcohol piece a little bit different, and that's okay. I'm just drawing it so you can kind of see the connection. So when we go to name this, if you remember from our ester video, this becomes carbon 1. And so our longest chain here is now 3. So the name of this ester is going to be, I'll just draw this in the bottom here so I have room, 1-methyl-propyl. So the name of our alcohol has changed in its ester form. However, the name of our acid will not. So in our acid, we still have 1, 2, 3, 4 carbons. And so we'll put a space, and we will have 2-methyl-butan-OH. So the only part of the acid name that's going to change is the ending, but our alcohol name has changed significantly.